But to kick us off for today's event, we are going to have a keynote speech on data quality as a risk. And delivering that, we are absolutely delighted to have joining us Muriel Foulonneau, who is the Head of Data Quality Management at the General Directorate of Public Finance in the Ministry of Economy and Finance in France. Muriel, thank you so much for joining us. The floor is yours.
Hi, it's a pleasure joining you today. As was just said, my name is Muriel Foulonneau. I work for the General Directorate for Public Finances in France, which covers different domains, including land registry, taxes, public accounting, and so on. So it's a large organization, about 100,000 people. And I joined the organization about 6 months ago. So as a head of data quality, and I wanted to share, or I suggested I could share some of my thoughts about data quality as I've been working on it. Faced the data quality issues over the years in different environments, in different contexts. So this is what I'm suggesting to do today. So data quality as a risk. The first thing I wanted to start from was the promise of the data economy. So we currently have regulations entering into force. We do have a lot of initiatives in different countries to boost the data economy by sharing data, and with the assumption that if we share data, that's going to create value. That's essentially one of the underlying thoughts behind all this. So this goes with a few types of impacts. So we say we're going to share data, we're going to publish, so public institutions, but also more and more we're encouraging companies, we're encouraging academics to share their data as open data. And open data is expected to have a lot of virtues. Creating jobs, creating employment, creating companies, changing organizations, gaining efficiency, and so on. And one of the things people have asked was, okay, data will create value if you share it and people reuse that data. So that's especially the case in the environment, in the context of open data. So if you open your data and you expect people to create value out of it, that assumes that data is reused. So you have reusers. One of the peculiarity of open data is that you don't always know all your reusers. So some people have tried to understand what is it that makes my data reusable. So I'm giving one example, the French organization for open data, so open data platform called ETALAB, launched a survey in 2020 with 900 respondents, more or less, and they came up with a few issues, and data quality was considered a major obstacle in that context to reuse. So they identified, for instance, issues in freshness, insufficient or inaccurate documentation, issues in dataset uniqueness. Not to say that this is not good as a whole, but there were a few issues that were raised in this context. Fortunately, we do have principles, the FAIR principles, making data findable, accessible, interpretable, reusable, and we do have a few other initiatives that help drive efforts on data quality. One of them was launched by Joiner, European Data Portal, you're all very familiar with. So this is an extract from a training resource that was done on metadata quality for open data, for instance, and it lists a number of dimensions of data quality that are important to look at. So data accuracy, consistency, availability, conformance to standards, and so on. But you do have a few other frameworks that suggest different dimensions. They're close, they're very close, but they're not exactly the same. So I'm giving you a few examples. This is a paper I've actually used quite a lot, which starts from information quality analysis and organizes different frameworks into intrinsic, representational, relational, and reputational quality with different types of dimensions. The IMF has suggested a few dimensions of data quality in relation with statistical data, I mean. You have here a suggestion on linked data. I think you will find a few peculiarities. For instance, if you look at statistics, you will have a dimension of interpretability. If you look at linked data, you will have interlinking as one of the data quality dimensions people can look at. And here is a study by DAMA, which is a large organization on data management, mostly industrial. They have published a research paper in 2020, the Dutch chapter of DAMA, and they tried to look at the different dimensions that were listed in different frameworks, and they ended up with 127 quality dimensions. And if you think of a dimension, and I'm not expecting you to read them all, but if you think of data quality, you're not there if you expect this to be indicators. Once you have one dimension, you can have multiple indicators as proxies to assess a particular dimension. So that can end up being quite complex. So one thing I've been thinking was, okay, I have, over the course of my career, reused data in different contexts, and I have seen a few data quality issues, and some of them did matter, some of them did not matter as much. And so I say, maybe I can look at the problem the other way around, instead of just thinking, okay, a data quality framework is something very useful because it gives good guidelines, and it's usually built from the experience of how much data quality has impacted a certain number of services or usage contexts. However, maybe if I look at my context, I can see a few things that matter and don't matter. And so I say, maybe I can share that experience. So the first experience I'm going to talk about is the construction of a distributed digital library. So what's a distributed digital library? Here you see Europeana, for instance, which is a European digital library. It aggregates metadata from thousands of cultural heritage institutions across Europe using different mechanisms. And as far as I know, it doesn't aggregate the content. It only aggregates the metadata that describe the content. And then if you want to actually see the content, you have to go to, there's a link provided to the institution website. You can see Data data.europea.eu, which is the official portal for European open data. And you have, in the same way, the aggregation of metadata about data sets, which are published on open data, as open data. And above is a project you probably don't know, which is a project I've worked on years ago, which was essentially doing the same. We were aggregating metadata from a few different institutions, so universities at the time, and providing access to hundreds of thousands of resources in that way. And the objective was to actually experiment what it means to share data and what it means to reuse data in this context. So the principle is you aggregate the metadata and then you share it. And when I started working on this, I had the feeling that there was an assumption that this is low cost and low touch, meaning it's easy. People have data. They already have their metadata they're working with on a day-to-day basis, and they share that. make that available to me, I can then aggregate that, provide a portal that's going to search through that metadata collection. That sounds easy. However, one of the person who had been practicing that kind of mechanism for a while, he was a computer scientist, and he had been working on the National Science Digital Library in the US with, I think, 100, maybe even more data providers. And he's a little frustrated that things didn't really go as expected. So here is a few of the problems I've faced. So one of the problem you face in this context is data is decontextualized, of course. So there was a story told by someone called Robin Wendler, who was working at Harvard University at the time, and they had a collection of pictures of Theodore Roosevelt. And because it was a whole collection on Theodore Roosevelt, obviously, people didn't think it was necessarily worthwhile repeating in the title, for instance, of every single picture that it was Theodore Roosevelt on the picture. So you had a picture that way, which was published and entitled On a Horse, without even a mention that this was about Theodore Roosevelt. So I had similar cases, which were slightly less entertaining than Theodore Roosevelt's case, but which were exactly the same problem. So essentially, when you aggregate, when you share the data, and you don't have the full context in which for which it was initially created, you have that risk of decontextualizing the resources. And this is an example I found on their website, which is from the same collection of pictures. So one thing we've done was to try to work with collection descriptions. So trying to have different data providers build the description of whatever collections they were sharing and which we were aggregating, and trying to check with actual user logs whether if we reuse the collection description, we would retrieve more content or have a different results in when customers try to retrieve content. And we actually found that for multi-word queries, in 17% of the cases, we would have one term of the query matching the collection description and one term matching one of the items in the collection, which kind of suggested there was a good potential for improving the quality of matching in those contexts. So another problem we've had was the pseudo duplicates. So we all knew the concept of unicity, so the dimension of unicity in data quality. It's simple. It's the duplication. You have two, in this case, two records. They're exactly the same. You remove them. And I happen to have had one of their data providers who decided to provide me with a description, so a metadata description of every single page of a book. So obviously what you see on the left-hand side of the screen is a representation of two metadata records for that book. Obviously highlighted all the differences, so you only have the page number different. So it's not strictly speaking a non-unique record, but it happens to be kind of non-unique for the purpose for which we're using it. So again, we tried a similar experiment. We ran customer logs. So we ran customer queries from our previous logs, and we tried to identify whether there were collections in which maybe records were not that similar. It was not, the case was not as obvious as what I just mentioned, but something that would make the data kind of near duplicate. That would be duplicate for a particular functionality of the digital library. So if you see on the right-hand side, this is a page I found in Europeana, and you have a list of items in the list of results, and there was no obvious difference between the description or even the title of what I could find in these items, meaning me as a customer, I'm not really certain which one to check, which one to look for. I gave you another example, which I found on the French Open Data portal, where you have, so in this case, it's actually quite different. It's two data sets. You don't need to speak French to see the difference. The description is exactly the same. The title is nearly the same. The left one is point of interest in Paris, and the second one is kind of a parkour in Paris. Other than that, every single word is the same. Meaning maybe it's accurate. It can be very accurate. It may even be very complete as a description, but it's kind of very similar, and it kind of takes a second to see which one is doing what and what is it I'm actually interested in. So another problem we've had was when you try to ask people, so data providers, to standardize the data they're providing you, you don't always get what you would have expected. So on the left-hand side, I mentioned a few cases of the property Dublin Core date. So it's a metadata property, which is also the date of the resource. And here, because usually the data was stored in a different format initially, it may have had additional semantics. It may be that the people who created the metadata wanted to say something additional. They wanted to say that, yeah, the date is 1985, but it's actually something that was planted in 1985. So they will add semantics inside the value of the metadata. You do have various as a value. So this is a few of the different types of values I found. And I made that list. So it's an extract of that list. I made that list when I wanted to write a normalizer for it. So you do see that some people will tend to say something like the 18th dynasty. So without any context, even impossible to interpret. So that's it. And it doesn't mean it doesn't follow any standard. If you see the question marks, for instance, those can well be planned in a standard. There was a standard in the library world that allowed you to specify uncertainty or intervals with square brackets and question marks. So it could be that they are following standards, just not necessarily a standard I know about. So at some point, we wrote a piece of code to actually create automatically thumbnails for pictures, because we thought that would be better for the results page. And we ran an experiment with 4 data providers, one of them being the Library of Congress. So you did have people very experienced in sharing their data, handling their data, and so on. 4 of them. And the 4 of them, they said, no, actually, don't do it for us. We're able to provide you with our own thumbnails. So I just specified thumbnails, and I didn't think, and I found myself out of 4 data providers with thumbnails of completely different sizes. So afterwards, I had a doubt, and I thought, what does it mean actually a thumbnail? So this is the only thing I found on the internet at the time, which was related to GNOME somehow. And which was giving dimensions of what a thumbnail could be. And I had something which was in the category of very small, and I had something above ridiculously large. So just to mention, it's quite important to be specific, because standardization, even among a single community, one would always get something unexpected. So another dimension that was quite impactful was the completeness for a specific user task. So on the left-hand side, you'll see we used Dublin Core data. So we actually used a slightly more complex format than just Dublin Core, but I've used Dublin Core as a way of simplifying the conversation. made some statistics on how many records had, how many occurrences of every single property and so on to assess the completeness. The problem is when you use that kind of information in a digital library, as you can see with the example of Europeana here, you will provide things like that, such as filtering results. So in this case, on the right-hand side, you can see that you can filter results by type of media. And at this point, if you do not have 100% coverage on the format of media, which is the case for all examples I checked on Europeana, they will provide full coverage. But I wasn't able to, because my data providers did not provide me with the format of their resources in all cases. And sometimes it's easy to guess, but sometimes some of the formats are difficult to interpret. And every single functionality you can provide here, if you have just 70% coverage, that means you will kind of have a part of your collection which is going to become hidden. So what we did actually at the time was to try to restart from what is it my user wants to do. My user actually has tasks, and in the case of digital libraries, the tasks are quite well standardized. So at the time, FRSAD was not published, so we started with the user tasks as specified by a standard called FURBA, functional, and then I don't remember, for bibliographic records. And they say what a library catalog must do is support the user tasks: find a resource, identify a resource, select a resource, and obtain a resource. And here you can see on the right-hand side, this is a catalog, and you have the function select, which is a list of results from which customers will or users will select resources. And this one will use the title, it will use a description, it will use the format of the data set, and it will use the source. So this is a limited number of data properties which are used by each of those functions. For other types of services, you will have different types of user tasks, and each time a subset of properties that are going to be used by those tasks, by the functionality of the service that will enable those user tasks. So a second example of something I tried to do by reusing data, it's educational test items. So we've tried to generate educational test items from different data sources. We started with with the linked open data web, with linked open data, and we also did it from specific domain models built for learning purposes. But I'm going to focus on linked open data in this example. So the purpose is to create a test item, so a test question, essentially. You have here a title, you have different options for multiple choice item, and you have variables for options, the keys. There's one good option, one right option, and the critical thing here is to find correct distractors, which are the wrong answers. So we built a pipeline with the web, starting from the web of data, a set of SPARQL queries from which we created variables, which we stored and then analyzed, and did all sorts of very interesting things, which are not our topic today. And then we generated test questions in the standard format for test items in educational content. So this is what it looks like. This is an example with something very factual. What is the flag of which country is represented by this flag? And so we reused data from Wikipedia, Freebase, and at the time, and yeah, and that was it. So as an example, here we started with a first set of test items. Out of 30 questions generated, 6 of them had a missing link. So that starts being a bit difficult to get directly reusable items. A second problem we faced was lexical consistency. If you try to extract data from linked open data, the lexical layer, so we most of the time talk about the semantic layer, so what the concept, or the concept's right. But very often we don't necessarily focus on the lexical layer, and I know I've worked later on with the lexical layer of the semantic web, but you did have a certain variability in the way in which people encoded the lexical data. So a king, for instance, he would be represented with Roman numbers and the nickname with Arabic numbers, and the official name of Charles, the names of France, and the last one with no nickname, for instance. So that means if you want to be able to reuse this data with lexical consistency, you need to do some kind of not always very easy reprocessing. Then some issues on data accuracy, which, so this is still in DBpedia, or was still in DBpedia a couple of months ago when I looked it up. So this is an example of Louis XIII of France. He was a king. I wanted to have examples of kings. And he happens to also be named the Three Musketeers, which obviously is not his name. It's the name of a French novel in which this king is a character. So this is a data accuracy issue. However, it also raises a question as to, in a graph, a large graph like DBpedia, which focuses on all sorts of domains, you also have information about fictional characters. So it can be a little tricky to also disambiguate between fictional and non-fictional characters. Another problem I found, so we tried to work with the models, the way in which diseases were modeled, and I found that rape was considered a disease. So it seems from the little digging I did that it might actually be a modeling issue. So it could be that this one was generated and it's not necessarily something we can directly do something about, but very often the reuse of semantic resources, not necessarily from open data sources, raise an issue in my experience that people may try to model things in slightly different way, and that creates sometimes a little bit of a difficulty. So quality indicators here. So we ended up trying to analyze our data sets, which we created for variable generation, and analyzing how good they were. So say you have a certain percentage of accuracy for each source of variable. If you require, say, 5 variables for each test item, what are the chances that your item is, at the end of the day, going to be actually useful? And here, I looked up a little bit what I could find in terms of data accuracy levels for graphs. So I found a paper where Yago, which is one of the ontologies underlying the linked open data, and DBpedia had an accuracy of 95%. Another graph, which was famous because it was generated from unstructured data, is NEL, and there's another paper that estimated its accuracy at 75%. So that's so you could think 95% is very high, but below I gave you an example of just a stanza from a French poem. And you see, that would be a 99% accuracy on OCR. So for OCR, fortunately, we're way above 99% accuracy on the task. Otherwise, it's actually quite annoying. And the level of accuracy, so when you define quality indicators for a particular context, sometimes I've heard people say, oh yeah, 99% it's excellent, or 95% it's excellent. Maybe it's excellent for a task, say a learning task, but it's not necessarily, it may be very low depending on the task or the amount of data you're going to reuse for each of the activities or tasks you're going to have to carry out. Then I've been working on a question answering system. So yeah, maybe I should have presented a little bit what I did in my career. So the question answering system I've been working on initially. So I've worked a little bit as an academic before. So the previous experiences, these are industrial experiences, and I've been working for Amazon and in a company called Comply Advantage, which is working on fintech, essentially. So I'm going to share a little bit about not the content of what they're doing, but kind of some of the lessons that the kind of tasks of question answering can make me think of in terms of data quality. So here is the purpose. You want to answer factual questions. What is the capital of Mozambique? Or this kind of things. It sounds very easy, and that's the kind of thing you can easily do from data nowadays. So we have multiple layers, but to answer this question, one of the layers was the use of knowledge graph. So how do you build a knowledge graph? You can use different types of data, which you merge into something conceptually coherent. So you have cold structured data, say IMDb, open structured data, such as Wikidata, and you have unstructured data, including, you could imagine all sorts of source resources, but you can start with Wikipedia, for instance. You will have unstructured data, and you want to be able to learn facts from that resource. Each one will have their own level of accuracy. They will have their own peculiarities in terms of format, consistency, and so on. And then once you collect them, you want to merge them into a graph. Here comes a problem. It's possible that some of them will have problems. Say Wikipedia, there is a problem of vandalism on some of the resources. You will have a close to perfect, but not quite perfect data extracted from structured data. From unstructured data, you will have a very, very good extraction algorithm, but sometimes it's not that good. So you want to prevent the graph from getting bad data at the entrance. So you have different strategies and a few algorithms that are possible to actually verify, carry out the task of fact checking. So the basic mechanism that people have been using is called the voting algorithm. That's essentially how many sources tell you that something's true. So here I gave you an example of, this is the birth certificate of Barack Obama. And if you remember, when Barack Obama became president of the United States, there's been an issue with some people claiming he was born abroad, so in Kenya instead of Hawaii. If you would have counted at the time the number of sources mentioning each of the assertions that he was born in Hawaii versus the fact that he was born in Kenya, it's not clear that the number of sources, the highest number of sources, would have indicated the truth. Another difficulty with this kind of approach is that you don't always have, for all types of facts, overlapping sources. So sometimes you will only have one or two sources giving you a piece of information, and it's going to be difficult to tell which one is right. Another approach is to use the credibility of the data source. So you will assign credibility. There are multiple ways in which one can assign credibility in an automated or non-automated way. There are styles like encyclopedic data sets, for instance, which will give you a hint versus social media, which are quite different. But you can also look at websites' characteristics. Have they been updated recently, or this kind of things? One thing that I looked at was the fact that data source credibility does not necessarily apply to all domains. So, for instance, BBC Sports may be very good in sports, but may be less credible if they're talking about politics, for instance. And some data sources will be very specialized. Another issue is data source quality tends to evolve over time. This is an example of a paper where they've been looking at how the accuracy of data from a single data source would vary over time. And it's not always that bad, but there are differences over time. So that still needs to be managed. Another strategy is to look at consistency with prior knowledge. So, in this case, you will create rules such as a person cannot manage a company if they're dead, a horse cannot fly. Yes, sure, but as I was mentioning earlier, in fictitious environments, horses can fly. And then if you look at prior knowledge, here you have an example of a study that the team I worked with did at Amazon. They've been looking at how you can create knowledge embeddings in this case. So a vectorial representation of concepts from a graph learned from a particular data set. So in this case, they used two different data sets. This one was from Facebook, if I remember, from Freebase, if I remember correctly. And they did that with another data set as well. And as you can see, if you look at prior knowledge, you will see that, yes, sure, it's unlikely a woman will be a data scientist, will be a scientist, because, yeah, over history, women haven't been scientists for very long. And so you will tend to reproduce biases and so on. So this work was to try to see if it was possible to unbias this kind of representations. So one thing I've learned was that if we try to label or annotate or fix data manually, we might think that will fix things, but humans are not perfect either. And sometimes annotator consistency, for instance, so inter-annotator agreement will be quite low, even on simple tasks like, is that right or wrong? And sometimes humans who do not work within a particular context and have to fix data, they will tend to make mistakes quite often as well. There's a major risk of getting it wrong for certain types of usage. So, for instance, here is the example of Microsoft's Teen AI, which has learned to be racist quite easily. I think it was in 2016. And there's such this can be brand damaging for certain types of usage. So that also means that data quality will become a critical thing, even if it's a very small number of errors or very small numbers of misplaced answers. The accuracy will have a huge impact, even if quantitatively it's very low. So another thing that I've wondered, if I ask you who is the president of North Korea, or if a customer asks you who is the president of North Korea, well, he probably wants you to answer the current president of North Korea is Kim Jong-un, right? Except that Kim Jong-un is not actually the president of North Korea. He's the supreme leader of North Korea. And there is a president of North Korea. There is an eternal president of North Korea. That's Kim Il-sung, who was actually voted or named eternal president a few years after he passed. And the thing is, if you answer your customer with Kim Il-sung, he may actually think you're wrong, even though you were correct. So what should you actually store in your graph versus what should you actually rephrase the customer's question? I'll leave you with that. So we're short in time, so I'm going to try to scan very quickly. I had another use case on anti-money laundering, where we were trying to find connections between people in companies to try to identify risks of money laundering. So what you do in that case is you can analyze company structures. So in this case, this is based on the UK Companies House, on not only UK's Companies House. This is the open ownership data sets, which you can find online, and it represents from an aggregation of data sets the company structures. So most companies in the UK, they look like the left-hand side kind of company structure, but sometimes they will look a bit more complex. So you can, the most important task here is entity resolution, finding that a person is the same as another person. The problem is, as opposed to the kind of large knowledge graphs as you have with Wikipedia, with Amazon Knowledge Graph, Google Knowledge Graph, and so on, in this case, you have to work with people who are not necessarily very famous, so you do tend to have scarcer data. So you do also have some issues due to international names, transliterations, the fact that sometimes in some countries name variability will change, and so on. You will have geographic locations which will change. So you do have a few issues when you perform entity resolution. And as I was saying, the completeness of data will be critical, because with sparse data, it's often very difficult to answer, is this the same person? It's actually unknown. So one thing I learned when I digged into literature was that, for instance, there was an old paper I found where some people have looked at how often a record in a customer relationship management database system, how often a record will change. And they realized 2% of the records in a customer file will become obsolete in 1 month, because customers die, divorce, marry, or move. In France, I think they analyzed the statistics organization that 10% of people move every year. So that means each data point will have their own risk on data obsolescence. So we did some exploration of the UK company registry, UK Companies House. We found a few odd things. So this one had the same name as a very as an official minister of Saudi Arabia, and he happened to be to have a significant influence in the registry on a company, interestingly called Ministry of Finance of Saudi Arabia Limited. So this was a little bit surprising. And then we looked at the accounting, and these people had, and you can count the zeros, that's £1 billion in 2021 and in 2022 still, and I think it was on a dormant account. So you look at connections through a graph. When you build a graph representation of this data, you find a few people connected to this business, and then you find these people connected to other interesting companies, such as Ministry of Finance of the State of Qatar Limited, Banque du Canada Limited, and a few of them also have £1 billion on dormant accounts. So that looks a bit odd, except that if you look closely, you see that Companies House does not verify the accuracy of the information file. And it's a very known problem that as a consequence, the official registry for the UK companies has a lot of quite odd information. So This was another example on data input interfaces and the fact that you could have honest mistakes. In this case, people suggesting circular ownerships of companies, which is illegal. It's actually very possible that that people have not necessarily used the interface or understood the interface, and very often data quality issues that can be tackled with HMI approaches. And this is another example where people will find, so this was in connection with a mafia case, so the London laundromat, where you had the names of people mentioned there. And when we looked at addresses connected to these people, we found that there are companies in theory unrelated, but through the address, you could relate them, except that people will add a space, in this case, between the 7 and the 29, intentionally or not, but it ended up being more difficult to create the links. So as a conclusion, I'll try to go very quickly on my conclusion because my time's up. Aim for excellence, but build services that are resilient to imperfections. What I'm trying to say is that there are quality issues of all sorts. They don't all matter equally. First of all, data has multiple roles in services. It's not only data that you show directly. You use data for all sorts of different roles, and their quality or different aspects of their quality will impact the final quality of your service in different ways. The other thing is intrinsic quality is not necessarily very impactful. It really depends on the context. And in open environments, when you publish open data for people to pick up, you don't always know all those reuses. So that makes it very difficult. One thing we've tried to do was to try to create a culture of high quality data. This example is a picture that was created, sorry, it's in French, but I tried to provide a short translation by our colleagues from the Ministry of Environmental Transition in France. They used someone to actually create those drawings. And this one represents when you say, oh, I'd like to have high quality data. Well, sometimes it actually takes, it's actually construction. It doesn't come naturally high quality. And so it requires a lot of work. The thing we can do for data providers to provide high quality data is show impact. When I'm unclear about which one I'm going to click on Europeana, well, maybe I'm going to end up not clicking on any. And this one is the famous case of Boris Johnson having to use incomplete data when taking decisions on COVID. I'm not sure he would have taken different decisions, but hey, who knows? This is an example of Google and Amazon researchers coming together and trying to think about how they could learn from high quality data. And one thing they're doing is trying to build systems which are resilient to data quality issues. So that's it. And I'm going to finish with that consideration from a very old work. So these were people, there was a Mr. Osborne who had to create a report on cataloging practices at the Library of Congress in the US. And he ended up using the word perfectionism to describe a hyper-emphasis on exactitude and precision, in this case, quality gone awry by being taken to an extreme. So my main message is show impact. It's very important. But yeah, we can also try to build systems to some extent resilient to quality issues. That's it. Thank you.
Muriel, thank you very much. It was a lot to get through in the time allowed. A couple of questions that have come up directly related to some of those last points you were making, in particular regarding the context and how important that is. But it's not always, as you said, obvious. What can be done if the context of use is not known?
So when we don't know the context, one thing we can do is to identify, as I mentioned, for digital library systems, for instance, you can have a few hypotheses on which types of services will reuse your data, or which type of usage you will use your data, and which kind of user tasks those are. So that's one thing you can do, set hypothesis. The other thing you can do is ask people. And internally, for instance, I've seen people in certain departments, they are actually looking for feedback from people who are reusing their data. And they build like regular meetings and so on. It's more difficult in open environments, but it's still something you can do, or you can try to interview people, look at how they work, what actually makes a reuse decision versus, yeah, it's an annoyance, but it's not really impactful.
Well, another question, again, you were mentioning about the data quality issues and how important, again, that is. In your experience, are the data owners you've met usually aware about those quality issues, in particular with their own data, or do you have to point it out to them?
Most of the time, people I've worked with are very much aware of the data quality issues they have. It's difficult sometimes for them to prioritize them, but people usually want to do things well, right? But it's not necessarily easy for them to prioritize if they don't actually know the impact. And I've seen a lot of people who didn't really realize necessarily the full impact of the data quality issues they had. I've met a few people, of course, who had data of excellent quality, which sometimes means you've not looked close enough, but most of the time people know. But it's really a matter of prioritizing.
And related to that, you said the ministry was interacting with multiple domains. And are there differences in how you see the quality across those different domains?
Um, Yeah, so you'll have different traditions in different domains. And again, the experience I had in digital libraries, for instance, was a good one because there were some researchers, they did a comparison of data from different domains, from libraries, from museums, from archives, and they realized that in different domains, there were different cataloging practices, which led, for instance, in museums, you will more often have works of art entitled uh, anonymous, for instance, untitled, or an author being anonymous, which you will not have in libraries. So there are different cultures, different practices, and sometimes it makes more sense. What is the title or the creator of the person, for instance? So there are a few traditions and peculiarities per types of domains, but yeah, it's about asking.
And then a final, very quick question. Any experience in using AI to deal with these matters, or any thoughts on AI in general?
Yeah. So the example I gave on anti-money laundering, for instance, there are a few things to identify, for instance, the risk on data quality, how much uh, you're going to be likely to have duplicates or to have the same person wrongly identified as two or the other way around. So ambiguous names and so on. So you can use that. You can obviously use outliers in your data analysis and so on. You can reuse customer feedback, which is a very important one, and try to take those into consideration to retrain models. Sometimes the length between the time you get the customer feedback and the time you are actually able to take that on board is going to be very long. So sometimes the feedback will take very long to come back because the customer task will take very long to give a result. So it's not always possible, but that's also the kind of thing we can do. So yeah.
Thank you, Muriel, for getting through as many of those questions as you have done, and thank you so much for your presentation.